Thanks, Nabil, for meeting with me again. I made some changes to the design. I think we talked about a lot of different stuff to modify last time, so I went through and made some edits. We discussed the magnetic attachment method, and I made a video about that earlier, about how we kind of thought that was a good idea and went back and forth about it. I think ultimately I don't want it to come apart, and I know it's like not super likely that would happen, but I think I like the more physical attachment better. So I kind of integrated some of what we talked about last time with this design, and what I came up with is kind of almost like a hybrid mechanism. I thought this would be kind of cool, is have like a printable label that people could print off to change, what material is in the container. So these are magnets that you can attach, and then there's like a channel inside of this that you shove like the other magnet in to make it magnetic. So thought that would be something that might be kind of interesting to play around with. And then I went back to a similar recessed design here, and then I mentioned it to you earlier, but I have this like a hexagon ride that spans the whole length of it, and I actually have one here. I don't know if you can see it very good, but it's threaded on the inside and has, it's a hexagon shape. It might be kind of hard to tell, but that would span, and then you could tighten it, and the metal would not pull out. I think I'm still kind of up in the air about this in general, but one thing I thought, if we did like a brass insert or something, if you're putting a lot of torque on it, that could pull out of the plastic. So I don't know. I guess, what are your thoughts on this overall? Obviously this is a lot flatter now. I know you mentioned the increased cost before, so tried to modify that, and you can see it's pretty flat now. And then this would be like a screw or some type of bolt that would screw into these leg pieces, and then these would be 3D printed. So all the blue parts would be something that could be 3D printed. So the reason I like the 3D printed stuff is, people who are buying this have a 3D printer, like FDM 3D printer. They wouldn't be buying it otherwise. So it's a nice way to let people customize. Yeah. And it's, there's not many product areas where you can say, like, we know for sure that somebody's going to have a 3D printer, but this is one of those cases where it's like, you would not be buying this at all if you didn't have a 3D printer. So I guess I just want to get your feedback and what you thought about it, and just what things could work or couldn't work. And then also, I know we talked about the rubber, I guess, feet situation. And so I modified that to where the idea with this is it would have a hole in the middle, and you would slide it on.
Yeah, you sandwich them between the two pieces.
Right, exactly. So that was just something I'm not, married to this design by any means. So I thought these would be fairly cheap, I would think, to make. There might be some, already available. So I thought that might be a kind of nice in-between situation. And then as far as the Airtight capabilities, I guess this would be a seal here, so some type of gasket. I know that's not really modeled fully, but that would seal off this hole that we would have in the side of the wall, and then we have the main seal here for the acrylic tube. And then I tried to make that more kind of characteristic of how you were describing it. This gap is probably too big looking back on how you drew it. I think these were like a smaller gap here, but this is kind of the overall concept. And then I have the insert, what would you call this? I guess guide,
a keyway.
Right, keyway. Yeah, that's the right term to put it in. And so I guess, what are your thoughts? And then another thing I was thinking about too is this main side piece is going to need to be pretty rigid. I know we talked about like glass fibers at one point, and also talked about ribs at one point as well. So what are your thoughts on like how we can make it, relatively thin and aesthetically pleasing, but also keep the structural integrity of it? Because we wouldn't want this to bow, and be kind of flimsy. So it'd have to be a pretty rigid material, I think. So just want to get your thoughts on everything.
Usually you go with ribbon. The thing is, like, we can use the ribbing for, let's say, aesthetic purposes.
Okay. Just make like a
that
cool...
would be one way.
Yeah, like a nice rib design. Where would you put the ribs? On the inside here, probably, or?
So, yeah, it will be on the outside.
Okay.
Be a bit complicated to put the ribbing with all the gaskets, keyways for the gaskets, etc. So you preferably don't want to like be unsmoothing that part. So just like you have it here with this, let's say, fit wheel, you could like go with a hexagonal pattern as the ribbing, and at the same time it looks good.
Kind of like with the 3D printer enthusiast pattern. Yeah.
Exactly.
Yeah, I like hexagon stuff. So The reason I put this is so that it would have, if it was laying flat, it would have like this would protrude a little bit. So this wouldn't be against the surface. And I mean, do we really need this? I don't know. I mean, I didn't want the screws or whatever to be scratching, whatever surface you put it on. So that was kind of
But we could
a
use like
makeshift.
plugs for the screws, rubber plugs. They would serve two purposes, like, hide the screw, of course, and like a nice rubber feet.
Okay. I guess the mold would encapsulate the plug so it wouldn't fall out. I just don't want
All
them
the
to,
shelf
come
parts.
off. Okay.
So all sizes of screws, they have like those plugs. I think they're made out of nylon, which is pretty rubbery.
Okay. I guess from your experience, like how would you determine how thick we need to make the part with the ribbing? Because right now it's close to 3 millimeters, like this thickness. I think it was like close to 3. So when you add ribbing, the rib would basically be something like that, I guess, like depending on where you're looking at it in cross section. But how thick do you know to make the actual rib part? Like how big does that need to be?
It has to be flush with the part first,
Okay.
like that. So it's just like a small ribbing, nothing too protruding. And about the thickness, that will be similar procedure to everything. But the main concern here that is gonna drive the ribbing is this force. And I can clear this. So we're gonna have like a force here. And these two surfaces, they're gonna be, let's say, a static bond. It's pretty straightforward simulation in ANSYS. We don't even need to go to mechanical. We just go to ANSYS Discovery, which is like, pretty intuitive. And you can do it like, of course, you can do it in Fusion if you have the extension. I tend to use ANSYS because I have like the academic version,
Okay.
which is free.
Yeah. Yeah, I've never used that before. And so you're just looking for where the stress is kind of localized based on the design, and then you'd add ribs to kind of counteract that.
So you do a couple of static simulations, and then you draw your conclusions for that. So you see where the stresses are accumulated, and that's it.
Okay. Yeah, because there's not going to be a ton of stress really on the part, because it's mainly going to be, depending on which orientation it's in, would be really where all the stress would accumulate differently. With it
Well,
upright,
mainly the
most of
stress is
the
going to come from
stress.
this.
Right, yeah. And then
So
if it's on its side, it would be kind of on the parts that are recessed, because the filament roll would, be laying on whatever part is pulling it, down from gravity.
yeah, I mean, we could go straight to simulation here. We can even do event analysis. So we're gonna go with static stress, create study.
The joints and stuff are probably messed up. I don't know if that's going to mess things up because I didn't really spend a lot of time on the joints, so I don't know if that's going to matter.
The components, we need this one. Here, if we go back to design, not generative design. Sorry, there's a lag between
And
my clicks.
I think you have to click cancel to get it.
Yeah. Okay, so we need to localize the forces that we're gonna, like the loads, and then the constraints. So first constraint is gonna be this keyway in all axes. And we could be like more finicky and can I do this? Yeah. Oh, it's pink. Yeah. Why is it showing all? Okay. So it loads. Oh, see, there's a problem there. We're gonna need to make a surface there.
As you can, I see what you're
yeah.
saying. It's like some type of.
Well, we're gonna need to either make the surface area that where the thread insert is gonna, yeah.
So like right here.
Well, wait, it's not gonna be like that because it's gonna be pushing from all the surface.
So you need to make a surface here, like the whole thing.
Yeah, I mean we could use this surface.
Okay. Yeah, you can go ahead and do it. Let me.
Okay.
There you go. You can take control.
All right. Okay. Oh, it's minnow steel. Wait. It's not showing the materials.
Try the down here. I don't know. Yeah, I don't know why it's not.
There you go. Yeah, okay.
I think everything is steel, which I just didn't change it.
So we're gonna find ABS.
There's a cedar resin. Yeah.
ABS plastic.
Mm-hmm.
We already have our constraint. No contact.
So basically, you're just defining the constraints so that the simulation will work right. And then you're going to apply a load just in that center port. Yeah, like that. Okay.
Let's go with, probably we're going to have a load of around 6 to 7 kilograms. So 60, 70 Newton. Let's go 70. No.
So where did you get the estimate from? Just thinking about it.
Just see how it buckles. Okay. And okay, what else we need? So good. The green. What else? Oh, automatic contacts, of course. So this generates the mesh, I think, and the contacts.
Okay.
Oh, we need to create the mesh too.
And so the mesh is basically breaking it up into little bitty triangles.
Exactly. Yeah. Basically, it's turning it into an STL. It's a bit more complex than that because I think we chose the adaptive meshing.
Okay. So it uses other shapes, probably different size triangle. Yeah, I've never used this before, so I'll be kind of interested to see what happens.
Already have our contact.
It's seeing the other stuff.
Okay, that's why when simulating stuff or doing generative design or something like that, what you want to do is first go to design and create a derive.
Okay, yeah.
So you have that model isolated.
Yeah.
And you have like a bunch of components flying around.
Do you make, like in SolidWorks and other CAD programs, usually you make the parts and you do a assembly at the end. Do you do that in Fusion or do you make it all like in one design usually?
I like doing it all in one design. So
it's
like
easy to like reference
approach.
stuff. Yeah.
Exactly.
Oh yeah, bottom up versus top down, all that kind of stuff. Yeah.
Exactly. Okay, where is it? There you go.
Nice.
Okay, and now we can go to simulation.
Yeah, I forget the derive feature. I'm glad that you showed that. What are you trying to select the inside or?
Yeah, these two surfaces. First things first, materials.
So you're saying that part is not going to move because that's going to be supported by the legs. That makes sense.
It's solve.
Does it color code everything?
Yeah. And you're going to see where the stresses are accumulated. You can create more loads. So, and more cases.
Yeah.
So you can like duplicate this case. So clone this one. And probably.
You could probably make one where it's like the shaft attached and then you could have like a downward force, like it's hanging, but you'd probably, I guess you'd have to model at least the shaft portion maybe.
Remove this part. It's probably not gonna exerts as much force as the tapered part.
Mm-hmm.
So that would be one. And then we could use simulation study. We could go check the thermal stress.
What would
The
that
event
be?
simulation would be the most accurate one. Well, accurate in the event of like this falling.
So that's for like almost like simulating a drop test.
Exactly.
Okay.
Requires more components, of course.
Yeah.
You want to see how the acrylic bounces against the rubber, the everything. There you go. I have
Nice.
the results.
So that's where it needs reinforcements, or where it's going to buckle first. That makes sense. So is that 1 or 2?
Here.
Is
We
this
have like set also a constraint here around the gasket. That was like a mistake.
Yeah, because that would be supporting or basically fixing it.
Exactly.
Okay.
Oh, we have a bad safety factor. Go to stress. You see that we're gonna need some ribbing here. Not too much. Okay, so let's fix this. We go to constraints.
Basically the whole keyway essentially. It didn't take too long. So is this sending off to, is this like processing locally, or is this?
Oh, in the cloud.
Okay.
This is the bombers with the Fusion simulation workspace.
Mm-hmm.
Because even if you have like a bunker's computer like I do, you gotta send it to the cloud.
Yeah, that is kind of annoying.
Whilst when working with ANSYS, I mean, I can do it all on my computer for free.
Yeah.
And results are like kind of immediate.
I'm gonna look it up. Let me see if I can. Interesting. There's a free version of it.
Yep.
Pretty
If
cool.
you go with ANSYS Academic or ANSYS Student.
Does it work on Mac, or is it only Windows? Do you know?
No idea.
You know, a bunch of stuff.
It's like limitless.
Fluid analysis.
I mean, the most complete one is ANSYS Discovery. It's very limited in what you can do.
This one. Cool. I wonder if it's done yet. Nice. Yeah, I mean, I thought, especially when it's compressed against the.
Yeah, I know I have like a
acrylic
really good safety factor.
Yeah, when it's compressed, I mean, the acrylic is like reinforcing it.
Yeah, we have like an 11 and 15. Can even go with a higher load. Let's go bunkers.
So, I mean, do you think it needs that many ribs? I mean, I would, if it could do without ribs, I think that would look cleaner, but obviously I don't want it to be like flimsy either. I just don't know, with the glass fiber, that would make it a lot stiffer, right?
It's going to make it a lot stiffer, but at the same time, a bit more brittle.
Mm-hmm. So if you drop it, it could crack or shatter or whatever.
Yeah.
Yeah, it's just balancing that, I guess.
The best material to add glass fiber to, it's nylon. It's PA6, PA12.
Mm-hmm.
It's the one used mostly like, on the power tools and whatnot.
That's more expensive too, though, right? Yeah. There's
it's what gives like the rugged feeling for those type of applications.
Yeah, I kind of like that in a way. I mean, another thing I wanted to ask you about is like the surface finish. Like I know some of them have like a textured surface. Is that something you do more like towards the end? I mean, they apply that to the mold, right? Like after the mold's done, essentially. Yeah,
it's like a finishing operation for the mold. There's the machining finishing operation, and then there's like they either sandblast it for a matte finish, or they polish it.
Okay.
For like clear coat.
Yeah, I think a more matte. I mean, I don't really like the super shiny, effect stuff. So I think more matte would be what I would ideally prefer. Yeah.
I mean, you see the stressors accumulated now?
Yeah, that makes sense. Just kind of at the edges of
these rings.
Mm-hmm.
So that's probably because we have sharp intersection.
Right.
We don't have like fillets.
Yeah.
So probably we should like make it smooth the transitions here. Let's go with displacement. Makes sense.
Okay.
So that's 0.78 millimeters. It's a good give. And the strain, yeah. So we're gonna need tiny ribbings here. So we can like even like a texture on the outside.
Mm-hmm.
So some hexagons or something nice. Yeah.
So just some type of like aesthetic reinforcement pattern type thing. Okay. Yeah, I can play around with that. And I'll also add fillets, like you're saying. I think that would probably help too. Do you think the thickness is okay? Like the 3 millimeter thickness, or?
Yeah, that's plenty for ABS.
And is there going to be, I mean, what do you think about, I mean, obviously besides the fillet, making the fillets and stuff, like this part would be a lot easier to manufacture overall because of it's a lot flatter than the other versions.
Yeah.
Okay.
I mean, you can imagine the mold.
Yeah. Pretty It's
going to be like
simple.
two parts. One very thin part, probably like a 10 or 12 millimeter steel mold, and the other side will be like the same, well, a bit thicker, probably 20 millimeter one.
Okay.
And then it will have like an injection point in the middle. I don't know if you want to go with the holes in the mold or drilled afterwards.
What do you think?
I mean, usually when you have like a bunch of holes, like more than 20, if you want to go in the mold, they're like at different angles. So like drilling all the time. But in this case, I would just have the mold and leave this part to be drilled.
Okay. Yeah, I made it taper. I would like for the screws to set like in the flush essentially.
Exactly. So that's why you want to drill it and then chamfer it. So that would be more precise. I mean, the mold will be precise too, but when cooling, you suffer shrinkage.
Right. Yeah. Okay.
So calculating that and having the fittings, it's a pain.
So just drill it. You don't have to worry about that. I didn't think about the shrinkage aspect of it, but yeah, that makes sense. You don't have to.
Yeah, I mean, you just like make a tiny hole or like a pin, right? And this would locate the drilling position, and that's
Yeah.
it.
Okay. Yeah, just a guide basically. Okay.
Exactly.
I like that. And then so make the ridges, modify that to like be pins. And then
Yeah, you can do the modifications here in the days.
Oh, here we go. Edges coming out.
Okay. So you see these edges, they need to be smoothened.
Yeah.
I mean, smooth transitions.
I think I did all that or most of it in the Revolve. Because remember last time you showed me how to make that profile basically, and then I revolved it. So I think I could just go in and modify that profile, and it would make the curves smooth.
Yeah, you don't want like this angled. So it's where stress accumulates.
Yeah, I like that. The simulation kind of demonstrated that pretty well. So what do you think about like on this part, like for the keyway? Would you? I guess that needs to be filleted too, just because of the stress situation.
Yeah. I mean, you don't have to go crazy with the fillets. Maybe a 1 millimeter fillet will do it.
Okay. Yeah. So is this derived from, if we made changes to this, would it change the original, or is it only one direction?
No, you see it's still linked. So probably you want to like break the link.
Oh, I see.
Make it modifications.
So, but now if we go to here and change this, it will update this?
Yeah.
Let me see if I can find that real quick. It's probably
Oh, you have a revolver there. So it's the first sketch.
Where's the body at?
I think because you have analysis.
Oh, yeah. I forget that all the time. Okay, there we go. Yeah. So now we could just modify. So you're saying just add these, like make these like 1 millimeter. I bet other stuff is referenced off of this.
No, don't do it like that.
Don't do it like that. Yeah,
because if you add fillets to you're not gonna have a consistent thickness. You have to go back here. So you add them
into this. Okay. Yeah, I remember you did this a little bit last time, but
so 5 millimeters here. Okay, the keyway. That's too much.
Did you see Prusa came out with a silicone printer option?
A silicone printer?
Well, it's like silicone. It's called Filament 2. It's like the startup company, but they made it where the Prusa XL is like one of the first printers compatible with it. And it's this filament that has like apparently the outer part is like plastic and the inner part is liquid somehow. And then it deposits the filament like it basically separates the hard shell from the liquid, like as it prints, which is kind of interesting.
So it's separate. Okay, I need to see that.
Yeah, they talked about it yesterday. They had some announcement. So
there's already a silicone printer. It's just like it's resin.
Yeah, I know. That's why it's interesting because the Prusa XL has like the 5 different tool heads. You just have to buy like a modified tool head. It seems like. I bet the filament's expensive though. I bet that's referencing the old profile somehow.
Oh yeah,
the body's hidden.
Very expensive. Yeah. Where's the body? Was it this surface or the other one?
I tried to do whichever one's lined up, so the left
it's
side.
This one.
Yeah, that's better.
Okay, we're gonna do that manually.
So the back side needs to be 4, right? If it's 3 millimeters thick.
Why is that?
I think that's like the end of the. All right. I bet you if you go back to the profile and then you can do like a full round fillet before you revolve if you wanted to.
Yeah, I mean, it's just because it's extruding. It's just the shot. Oh, no. Okay.
It's almost like a frisbee looking. So you're just checking for draft angles.
Yeah.
And you took it from that like center. Okay.
As long as it's green, on the clear.
Where did you find that at? In spec?
The draft
Okay.
analysis.
Gotcha. Yeah, I've never used it, but I mean, I'm aware of the need to have drafts, but I didn't know that was a
So
feature.
here's the window. So
So it's just
usually,
checking for 2 degrees. Okay.
exactly. So 2 degrees is like a lot.
Right.
So usually you just go with 1 degree and stuff like that for small molds, like
Yeah,
bigger mold tools.
that's the stuff that like I just don't know how you figure that out. Like it makes sense it needs a draft angle, but like how much of a draft angle, I have no idea.
Well, it depends on the material, of course.
Okay.
So there's materials that they flow really, really well into molds,
Mm-hmm.
and there's like sticky materials that don't want to release, or
Yeah.
I mean, they're just too gooey.
So it depends a lot, I guess, on the adhesion of the plastic to the mold, essentially.
Yeah, and how it flows.
Okay.
We can even do a simulation with that. So if we go like simulation, we have a new simulation is like injection molding simulation.
Mm-hmm.
So yeah, basically it's that. Okay, now we can.
Yeah, I bet all this is. I think I referenced off that some of the edges that we deleted.
Yeah, I mean you gotta go
yeah,
step
I
by
can
step.
fix
Whenever
that.
there's a warning, and like fix it.
Yeah, so we have all that, and then I wanted to ask you too, real quick about what's that one? This. So should I make this smaller?
Yeah, it's a bit too much, but it will
Okay.
work too.
Okay, and then I can print some of these off with the silicone. I have like a 50 shore elastic, which is still relatively high.
Probably you want something more medium.
Mm-hmm. Like 30.
85.
Oh, like higher. Okay.
Yeah, like more rubbery.
And so you mentioned that. What was it? What was the
Oh, the
material?
RTV gasket.
This stuff. I haven't bought any yet, but I was going to. So how would you, I guess, if I bought this, how would you make this prototype with that? Would you make like just a mold for it and then it would release out of
a
it?
one-way mold, not even like a two-way mold.
So you would what would that look like, I guess?
Would look like a 3D print. Okay, let's derive this.
You just subtract that out of like a solid piece.
Exactly.
Okay.
And then you just smoosh it. So you go with the tube all around the mold.
Mm-hmm.
You just smoosh it, and with the spatula, you just smoosh it into place.
Okay. And which side would you leave? Do you have like an opening, or would you have like a separate piece that forms the like center part, I guess? Does that make sense?
You mean this part?
Yeah. So so I guess we can make did you make I guess we can, how do you derive? Is it up here? Oh, there it is. Yeah. So you would, I guess, make like, wish I had a good spot to whatever. Obviously it would be a little more careful than that, but
Keep the tool. Keep the tool.
yeah, that's what I was trying to. There we go. And so I know it's going to be not this size in reality, but how would you? I guess it's that one. So how would you? Would you open it up like right here, or would you have like two pieces come together? What would you do from here? If you, I mean, obviously make it smaller, but besides that,
All right, so I'll do it something like this. So this would be the main part.
Mm-hmm. And you would split it, or
No, I would do like another part.
okay.
Mm. Copy.
Oh, I see what you're gonna revolve the outside. Oh yeah, I forget the intersect. It's pretty smart. Okay. And so you would just fill that.
Exactly. So they have like this part. So you fill this and then
Mhm.
smoosh this part against it.
And that would, you might have like a little tiny air bubbles or something, but it would be a good enough functional, basic,
Yeah, I mean,
rough and quick and dirty
good thing
prototype.
about RTVs, like, so you fill all this keyway, like all to the brim, or
Hmm.
not, and you smoosh it, like, you know, making sure you access all the parts. And then you press this. Of course, you're going to need some clearance here.
Yeah. Q like
This
point one or point
like
two or something.
0.2 something.
Yeah.
Also on
I
this
see what you're
side.
saying now.
There you go.
Nice. Yeah, that'd be easy to make with the resin printer. Real easy.
Mm-hmm.
Okay. Yeah, and then you'd have a little flashing, trim that off, and then should be a
Exactly.
decent
So
enough.
it's going to be flashing, and you can trim it with like any spatula, like metal spatula.
Okay.
And then you try to press this. Let's thicken it. We don't brick. Maybe just like some clamping. You clamp this to this, and that's it. 4
Yeah.
or 5 clamps.
How quick does the RTB stuff,
I
does
don't
it
know.
harden up pretty
Probably
quick?
I think it's pretty quick, like 5 or 10 minutes.
Oh, okay. So you could do it pretty easily. All right.
Yeah.
Cool. You said you sprayed some type of like oil or something to get it
Sorry?
not, do you spray some type of like not demolding, but some
A
type
release
of
agent?
yeah,
Yeah, probably
release
you could use like some silicone spray or Teflon spray.
silicone spray. Is that what it's called?
But yeah, silicone grease or spray grease or something. There you go.
So just anything
Teflon
like
is way
that.
better, actually.
Teflon.
Oh, but the Teflon grease, you see, just type spray. That's it.
Okay. Grease spray. All right. Yeah, I'm gonna buy
There's
some of that.
also some kind of waxes that are used for carbon fiber and stuff like that. But those are pretty expensive.
Yeah. Okay. All right. Well, I think I'll probably prototype this. I might make the circle a little bit smaller, and then I'm gonna work on kind of refining this a little bit, making it smooth, attaching these again, obviously, and then talked about making the inserts for this where it'll be a little more functional. And that's another thing. If we went with this design, how would you embed? So they make that ride as a female on both sides or as a male on both sides. So if we did the ride, and like the ride is just like a solution I thought of, but I mean, there's probably better, more cost efficient ways to make that part. I guess, what are your thoughts on that mechanism? Because we'd either like the side piece that twists, that's going to have to either be like a male or a female, thread, right? So like what are your thoughts on that in general?
Well, if we're gonna go with this solution, the idea would be to let's hide this thing. The idea would be to embed a screw in this part.
Is that
So
hard to do?
not hard. Requires some manual labor, but yeah, you see this thick part here, which is a no-no.
Right. Yeah.
Okay, so we could find it to embed a screw here to keep like the thickness constant. And this screw will be metallic. It's going to this part. Now the part is gonna be like an insert that you're gonna heat to insert, or just melt some plastic on top of it, like encase it.
What do you normally do in that situation?
Well, that will require some kind of research because, okay, let's see one product that has something similar. Okay, you see those lasers, like, leveling lasers?
I can look it up. Are you talking about just, let me see.
Yeah, something from Bosch or something.
Talking about this type of stuff?
Oh, okay,
Where
these are
they,
pretty, exactly. Like tripod. Yeah, you see they have like multiple mounts. There's like this mount here. You see the screw is embedded here.
mm-hmm.
But it has like a pretty big surface here. There's another insert under this machine. I mean, something smaller than this. Let's call it.
Trying to think. So this is a little different because that's not embedded all the way. So these are
mounts for pry tops.
Right. Trying to think of something that's like that. So is it like a special? So is the screw kind of like? I guess I'm trying to envision like what the screw even looks like. Is it just a regular
It's a regular
one of-
screw. It has like a rough side. That's like against the surface area that contacts. Yeah, exactly. It's like these. Where are they? Here you go.
Did you find one?
Yeah, I think it was in the previous page. Can we do plastic embedded screws or screws embedded in plastic? I'll look in McMaster-Carr.
Well, there's just, I don't know why it's so hard to find some of this stuff.
Yeah.
Because I guess from my perspective, I'm thinking I guess
it's
like
called male threaded tapered heat set insert.
Inserts. Okay. So like that. Okay. So it's pretty similar to like a brass insert. It's just a male version.
Yep.
Okay. Well, I can find that and embed it, I guess, with like in Fusion.
Probably
pretty
this
easily.
one would work better.
So do those, I guess do those strip though? Like, is it easy to strip that type of stuff? Because I've used some overmolded, threaded parts and they don't seem like they're easy to. I would be happy to use brass inserts because that'd be way cheaper than the hexagon, metal rod thing. But I just think about like, will they strip very easily? You know what I mean? Like when you're twisting on it.
Well, you're twisting inside. And we have like a limit to it because we have like a tube and some gaskets like taking off that force. So it won't be a problem.
Okay. Well, yeah, I'll find. So you said that like that version is probably trying to
because we have like a flatter side.
That one.
No, this one.
Okay.
Or even this one. So because we don't have like that much thickness.
Yeah. I see what you're saying. Okay, cool. All right, yeah, I didn't know really to look for those, so I can add that pretty easily, I think. And I mean,
you just downloaded the McMaster-Carr from Fusion library.
Yeah, it's like here.
Exactly. You need to log in.
I don't think I've ever done that. I've inserted without logging in before.
Try again, maybe.
Yeah, it'll let you.
Like a bulk or something. There you go.
So I don't know. So I'm just going to have to find one that's not like that long, I guess. Okay, I can find that pretty easily. So we can put that. Okay, would you, I guess from a usability standpoint, I'm trying to think if it's better to make, the top have the male component or the top have the female component and then this have the male component. I don't know.
It will be way easier if this has the male component.
Which part?
This bus has the male component and the female would be here.
Okay. Yeah, because it has like a natural recess anyway.
Exactly.
Okay. I'll play around with changing that up. And then, it might be a situation where we just make the center, like have an injection molded part for that part, for the center part. And then we can do like the 3D printed legs, I think would be like a good kind of compromise. Because I don't know if it would be easy to make it where people could, embed that male component easily into the like axis, the cylindrical part that the filament like rolls on. So
you're right. Can even be a through hole thread. So probably if we have like a thread, it goes like that.
But would that be airtight around the thread?
Yeah, of course, because we need to still melt the plastic here.
Okay. Yeah, I'll think about that. I like having it where the whole like outer face is like a single melted piece of plastic, I think, if possible, just to prevent any like potential escape
Leakage.
routes, I guess. Okay. Well, I can work on that for sure. And then talked about making the inserts for this where it'll be a little more functional. What do you think about having the gasket, like the airtight part for this? I guess my thoughts on this, like twist down, tighten part situation, is you kind of want the force to be as close, or in my mind, as close to like the ring as possible, just for like to make the force, I guess, more concentrated out towards the periphery, like the perimeter. And that's part of why I made this like a little bit bigger. Where would you put this gasket part? Like, would you put it more on the outside? And then I also thought too, well, if we're twisting this down, this is going to wear over time because there's friction, as you like tighten it, where this is scraping across the surface essentially. What do you think about like the position? Because this is just to basically seal like around this essentially.
The gasket needs to contact something.
Do what?
So this gasket needs to make contact against something.
Yeah, it would be against that.
Just make a keyway. That's it. Of course, you're gonna need to thicken this rear side, of course.
Yeah. Okay. But as far as like assembly of, would you we need something to guide whenever they're assembling this, whether I guess it would be glued or something to make it where they can put that in the right position. Would you make like a keyway here too, like a little cutout, or how would you do that so that they have it in the right
It
spot?
depends on
I
how it's
guess.
gonna be bonded to the side. Is it gonna be glued?
What do you think is the best option?
Gluing is messy. Usually, you just wanna fit it. So you want a complex shape here that's like presses against, and then you just slide it in, just like what is done in cars, like car doors and whatnot.
Okay. Yeah, like the door seal where it's a funny shape kind of that
Yeah, exactly.
gets caught in the plastic.
Yeah, I mean, you could like have something that slides outward or inward, or probably outward.
And that kind of catches it and holds it in place.
Exactly.
Okay. Is there like standard versions of that I could model off of? What would you search for that? Like physical, it's like a gasket, right?
Round gasket.
I don't know if it's actually 100 millimeters.
There you go. See?
So it's kind of like an O-ring. I feel like O-ring and gasket are like semi-interchangeable, but I think about O-ring as like this almost.
It depends on the diameter and everything. With O-rings
Yeah.
and gaskets, they serve the same purpose.
Right. Yeah. Oh, but what?
So that Buna gasket,
This one.
yeah, it's a $10.
Yeah, it's expensive. I guess that's because it has this mesh thing in it, which we don't really need. But yeah, but I kind of it's almost like a round gasket with flange or something like that.
Sort of a bit too thick.
Because this kind of has like that little lip on it. And then this one has some form of lip. And that's like way too much. I think I would probably just look through
Yeah,
MasterCard.
you see those? They already the glue in applied. So yeah, like this one.
Yeah, like a adhesive on the back. Okay. Yeah, I
That's
mean,
an
I'm
option.
not like anti-glue, but I agree that it's a little more messy, and I just feel like I don't want it to come off either.
Well, if they come already with the glue applied, so it's just it's not messy at all. It's like a 3M tape.
So just a adhesive back, and then, but would you? I feel like having like a small, like the guide, whoever's assembling it, right? Just like a little bitty cutout or something like that.
Yeah, just a visual marking, probably like a textured surface, just like to guide the operator.
Okay. Yeah. Okay. Well, I'll add that too, and then probably make this a little more. I mean, this part is it can be changed. Obviously, it's more just for. I like having the ridges because you can have something to twist with. But I think this is a pointy corner, so you got to modify that some. But that's pretty straightforward. Well, I think that's mainly the questions that I had. Do you think this is a okay solution for the feet or not? Like the little rubber.
A viable one, as long as the shore is pretty hard.
Yeah. Yeah, you don't want it too soft where it's not supporting anything.
And probably less rounded the edge.
Yeah. Less of a fillet on it.
Yeah, because you don't want to be this twisting to the sides. So you need as much contact with the ground as possible. It's like a tire.
Yeah, and we can make it. These were just some I modeled kind of quick, but they could be a little fatter if we can find some that are more thick, I guess. That hopefully won't be a challenge because it's pretty simple shape. And then as far as like this 3D printed part, I mean, I've made parts before where there's like a hex cutout like inside here, where you insert a nut and then it's a basically you create a nut insert. If you're printing this, you'd print it like that, like upright. It's kind of hard to see,
Oh yeah.
but I could have an
You mean
insert here.
yeah? You mean like a seat for the hex insert or for a lock nut or something?
Yeah. And that, I mean, that would be pretty tight fit. I guess the one other thing was a little like not concerned about, but wondering is this going to mess up? Oh yeah, we said we're just going to drill this out, so that shouldn't be an issue. Would you make this thicker here? I mean, I like how it's seamless, but do you think it would be worth trying to like make this part a little thicker, or that probably would mess up the mold just from a flow? Because I know you want the walls to be basically the same thickness.
Yeah. I mean, probably it's gonna miss a bit because if somebody over tightens here, it's gonna smoosh too much and look too much. So you can widen the hole or something like that. Or just add some too much stress there that can crack. That would be one concern. Keep like, I wouldn't taper the hole and use like a button type screw.
What does that mean? Oh, you're talking about like
I mean, there you go.
but we were going to have some type of like cover on it, right?
Yeah, there you go.
So something kind of like that.
This is too fancy, actually. Can you go back? Yeah, something like this. Something like this.
I just don't want them to come off. How would
Or
you
Phillips
that?
almond screw covers.
Which one were you looking at?
This one. As long as they're rubbery, so they can act as feet.
Yeah, I'll look into these. I like the idea for sure.
IKEA furniture uses this all the time.
Okay. Yeah, I mean, it would make it look cleaner too if it covered it up. These aren't horrible, but I don't like having the little. I would like for it to be just a seamless plug. Or I wonder if you could make it where where it could fit into the mold like around it, if that makes sense. That would be a little more challenging to like
You
design
see
it. I feel like.
these are more like
Pro
these
snap
also are
cap,
really nice.
classic self tapping screw caps. Okay, I'll look into that. And it's kind of interesting. Yeah, I like the idea of having basically using that as the feed as well. I guess, well, the only thing about that though is if you're trying to stack them like on their side, you'd have to line them up. You know what I mean?
Yeah.
Like if you had, like 4 feet and you're stacking
Yeah,
it like that.
Yeah, they're gonna protrude and
Yeah, it'd be a little messy trying to align them perfectly. I think that was kind of the concept of why I had like this circle, just so it would still need to align. And honestly, I don't know if this could be moved to here as well. I mean, there's different options for that. I just want to think it through. Okay, I'll think about the screw heads, and I'll probably order some and print off some stuff just to prototype some things now that I think we're in a pretty good. I mean, I like where we're headed. I think it's pretty coming together. I mean, obviously, there's still a lot of parts to fine tune, but I feel a lot better about the overall like design concept now, and that it could actually be, legitimately airtight, which is the whole goal of it. So,
being airtight doesn't mean it's gonna take moisture out.
right, yeah, I understand that. I just don't want it. I just feel like there's a lot of like different products or things that claim to be, you know, airtight or whatever. And like I get wanted the second, and it's not gonna pull moisture out. I just want to prevent more moisture from getting into it. You know what I mean?
Yeah, I mean, if you spend like 2 or 3 hours drying a nylon filament, the minute you take it out of the oven, I mean, it prints well for 20 minutes and then bye-bye. Starts.
And that's the goal. And I think it's not gonna. I'm not gonna overpromise. I just wanted to actually, do all we can to make it.
There's actually a way, but it's gonna require like, a vacuum. I mean, if we have like, say a vacuum valve here, and we could seal this, and it creates some slight vacuum. It doesn't have to be like, a 0 atmosphere thingy. Probably like, a third or fourth of the atmosphere. That's gonna pull considerable amount of water from the filament.
Yeah, I guess it'd be similar to like pull when you have like those storage bags for where you suck a vacuum on it.
Yeah, those vacuum bags. And,
Right. Yeah, I don't like the bags either. It's kind of
yeah, and then most of the time you need to be throwing them away
right.
because they rip apart. And
Yeah. Yeah, that's something we can think about that. I want to get this to where it's like pretty well done. I think if I have a couple hours, I can get pretty close. I think now with some different ideas you've given me as far as making it work. And I think that it's coming together pretty nice. So, all right. Do you have any other ideas or thoughts on it?
yeah, I mean, I'll fix this fillets first.
Add the orange back.
Exactly. We can like think about like other motifs here for the. This is too rugged. Probably so. Yeah, more artistic.
Yeah, I just made that kind of quickly just to get the concept down. But yeah, we can mess around with what that actually looks like. I just want to have something to grab, when you're tightening it. When you're, yeah.
And that's a feature that can you play with to make it like more.
Yeah, I'll get to work on modifying some of this and get a little fine tune. I'm gonna order some of that RTK stuff and probably make a gasket kind of quick and dirty version. See how that works and kind of go from there as far as like the design goes. But I think we're getting headed in the right direction for sure. So
Yeah, cool.
all right, well thanks Nabil, and I'll keep in touch and appreciate your time and thanks for all the feedback and pointers.
That's cool.
All right, have a good day, man.
You too.
Appreciate it. See you in the next one.
See you. Bye bye.